How's it going, everyone? Welcome to today's video. For today's video, we're going to talk about double replacement chemical reactions. A double replacement chemical reaction is just a chemical reaction between two compounds, so molecules with more than one element in them, more than one type of element in them at least. And they typically follow this particular format right here, which is we have a compound with element A and element X bonded to each other, going into a chemical reaction with a compound that has element B and element Y, whatever those elements are. One is typically negative in charge, the other is positive in charge. And when they undergo their chemical reaction, they're going to want to separate from the element that they are currently bonded with and bond with the element of the opposite charge in the other compound. So we end up with A bonding with Y over here and element X bonding with element B over here. Let's go ahead and take a look at a few examples of what that looks like. Okay, example 1, hydrochloric acid, that's HCl, plus sodium hydroxide, that's NaOH. This is a very common chemical reaction in titrations where you take an acid and you try and neutralize a really strong base like sodium hydroxide in order to do just kind of basic stoichiometry. But let's go ahead and use this as an example. First step, same as what we did with single replacement chemical reactions. I'll post a video of that up here if you need to look at single replacement stuff. Hydrogen, we need to write the valence charge for it. That has a charge of +1. Chlorine has a valence charge of -1. Sodium is in group 1, so it also has a +1 charge. Hydroxide also has a -1 charge if we look at our list of common polyatomic ions. Now, the reason why we do this is we try and figure out what's going to bond with where. Now, you can kind of do algebra, distributive properties kind of thing where, we just go outside here and inside here, and that should always lead you to the right answer as far as what products are going to be over here. But the reason why it is the way that this is because why hydrogen bonds with hydroxide is because hydrogen is positive, hydroxide is negative. They're going to attract to each other just like magnets would, a positive end to a negative end, and that's why they bond with each other. If it was hydrogen and sodium trying to bond with each other, they wouldn't form that connection. They would just repel each other, just like holding two positive ends of a magnet together would. And then that's the same reason why chlorine bonds with sodium over here. Sodium is positive in charge, chlorine is negative in charge. They attract to each other, and that is what they end up forming. They will end up bonding with each other. So let's go ahead and write it over here. We figured out what bonds where. It is going to be, we'll start off with that first one, HOH plus, we write the positive ion first, sodium and chlorine. Still see that? Yes, we can. The reason why I wrote HOH like this instead of H2O is to show that when water is involved in a chemical reaction, it is usually split like that. One hydrogen leaves, a hydroxide forms, and then that is how they participate. That's also how they recombine when they are separated initially during a chemical reaction. Just to kind of finish this up here, the final step is to check out the charges, make sure that everything is balanced as far as their overall net charge. Make sure we don't have to add more or less of another element. +1, -1, those balance out. HOH, it's water, that's all good. Sodium chloride, +1, -1, those balance out, that's good. So you end up with water and table salt. That's it for example 1. Let's go ahead and take a look at another example. Okay, next example that we're going to look at here, sodium bicarbonate and acetic acid. This is actually baking soda and vinegar reacting together. First things first, same thing as last time. We just got to check out the charges. Sodium has a +1 charge, being in group 1. Bicarbonate, that is HCO3, has a -1 charge if you look at a list of common polyatomic ions. hydrogen all alone here. This is a +1 charge, and this is acetate that combines with this hydrogen here to make acetic acid. Acetate also has a -1 charge. So we take a quick look here. We follow sodium is going to bond with the negative over here because it's positive. Bicarbonate, oops, let's go down here, is going to bond with whatever's positive over here because it's negative. So we are going to have NaC2H3O2, sodium acetate. And then I'm going to write this down here because I'm running out of room on my whiteboard. That's sodium acetate, so that's done. And then that is H and HCO3. So some might write HCO3, but we're going to actually write H2CO3. And some circles writing HH might be accurate, but this would be how to write it. Got to take a look at the charges here. This is just a hydrogen and a hydrogen combining. That's a +1 and a -1, so this is going to be good. Sodium and acetate, that is a -1 and a +1, so that's also going to be good. This would actually traditionally break down into a little bit further into H2O and CO2. But if you're in a high school class, it probably lets you just stop right there. This is what makes those bubbles that you see when you combine baking soda and vinegar. All right, that was the second example. We're going to take a look at one more example, one that might be just like a little bit more complex there, so just make sure we hit it all. Okay, last example. Same thing for the first step. We got to take a look at the charges. Magnesium is in group 2, so we put a +2. Hydroxide has a -1 charge. Hydrogen, +1. Chlorine has a -1. I can't remember exactly what. This is magnesium hydroxide. This is in an antacid tablet. If you know which tablet this is in, I'm not sure if it's Pepsid or Tums, but write it down in the comments because I'm actually curious to what antacid tablet this is the main ingredient in. Most of it is in other things. But anyway, we'll take a look. Magnesium, positive. We got to find the negative. Chlorine is negative here, so that's going to bond with that. Hydroxide, hydrogen is all that's left. They're going to bond with each other. Let's go ahead, write it over here. So we'll write magnesium with chlorine, hydrogen and hydroxide. We need to take a look at them again. Magnesium has a +2 charge. Chlorine has a -1 charge. We need a little bit more chlorine, so we add another one there that has a overall -2 charge over here, overall +2. We're good. So we'll put a 2 because we have 2 chlorines here. Hydroxide and hydrogen, that was originally just split before. We can see that that's clearly water, but you know, this is a +1. This is a -1. Those even out, so it's good. Again, we're going to save balancing chemical equations for another time in another video. Thank you for watching today's video, though. I hope you were able to learn a little bit about how to predict products for double replacement chemical reactions. If you found this helpful, leave a like, subscribe, helps out the channel, and I look forward to seeing you guys in the next one. Take care.